Hello students, welcome to Physics Wallah, Gate Wallah. So I myself Shivam Dixit welcoming you all on behalf of Physics Wallah and Gate Wallah. So basically we are in the series of Gate PYQs for aerospace, and I already have completed one subject, that is basics of thermodynamics. So basics thermodynamics part I already have completed 2 days back, and today I am here for aerodynamics part. Very good evening, very good evening, Stark, Ananya. Okay, very good evening and very warm welcome. And so today we are going to solve some of the good problems, mostly like journal problems which are frequently asked in aerospace gate related to fluid mechanics or aerodynamics, right? So those questions we are going to solve. Fluid mechanics, what about aerodynamics? Aerodynamics only, this is a part of aerodynamics only we are going to discuss, don't worry. So aerodynamics only we are going to discuss here. So we already have discussed some of I think strength of material already over. So approved sir have discussed some very good questions related to the strength of material. Then vibration part, Ramanand sir already discussed few questions. Basic thermodynamics part I already completed. Then today we are going to talk about aerodynamics. In that aerodynamics there are multiple things actually, right? In aerodynamics syllabus if you see, multiple things are there. Majorly it is a fluid mechanics part there, and the lift, drag, boundary layer theory, all those questions we will discuss today. Okay, and hydraulic machines I did not find because like last class some like one student was asked, right? I forget the name. One student asked about, sir, please solve the problem of hydraulic machines, but I did not find any questions or hydraulic machines. Are you sure hydraulic machines are there in aerospace? Maybe that student might be from mechanical background, that's why he was asking. But at that day someone asking about hydraulic machines means, so hydraulic machines are basically not in the syllabus as per I seen the previous year questions. Turbo machinery is there, right? Fluid mechanics is the basics of aerodynamics. Yes, this is the basics of aerodynamics. So that part only we are going to discuss. Hydraulic machines are not there in your syllabus. Potential flow is there, and lift and drag is there. Okay, boundary layer theory, flow through pipe also some questions are there. Dimension analysis, some questions are there. Model studies questions are there. Frequently asked topic I'm telling you, right? So I have seen that in aerodynamics, right? If you see, yeah, it's not there. Yeah, but at the like 2 days back when I have taken one session, in that session some students were asking about hydraulic machine question, but maybe he may from mechanical. Compressible fluid is there, compressible flow is there, so that will be covered, correct? Vinod sir will cover actually that part. We have already divided the subject because in our aerodynamics branch, right, in our aerodynamic branch approximately 5 to 6 faculties are there, so the syllabus is divided. So basic thermodynamics part I already have completed. Even in paid batch also I have completed. In applied thermodynamics part and jet propulsion part, compressible fluid flow, right, that would be mostly discussed, right, by Vinod sir. And today I am going to talk about the fluid mechanics part. Okay, so majority number of questions are there. So what I have seen that there are very less number of questions in fluid static part. In mechanical if you see, right, in civil if you see, there are lot of questions based on pressure measurement system, hydraulic like hydrostatic forces, right, buoyancy. So there are very less, 1-2 question only I have seen, right? So there are very less number of question as far as fluid static is concerned, but there are very good number of problems in fluid kinematics. I have seen some questions of stream function. I have seen some questions on stream function, velocity potential function. I have seen some question from this one, continuity equation. I have seen some question in acceleration analysis, rotational component also, vorticity is also there, some questions, right? So overall, I have seen that most of the part of fluid kinematics is covered, or question were asked from fluid kinematics part. Most of the part is asked in aerodynamics. Fluid dynamics is also very much important for you, because I have seen that questions are from linear momentum equation. I did not find any question in angular momentum equation, right? I did not find any question on angular momentum equation, but linear momentum equation and Bernoulli equation and continuity equation. So in these three questions are there in your topic. So I personally feel that whenever you are revising, aerospace student I'm talking about, so whenever you are revising, then you need to give very less focus, right? Only you just have to go through it. No need to practice much in fluid static part, even though you have to study it. Why? Because without fluid static, how can you proceed for fluid kinematics and dynamics? But fluid kinematics and dynamics, you have to give full priority. Even I have seen that less questions in pipe flow, right? Pipe flow or flow, like laminar flow, turbulent flow, very less number of questions are there. Majority questions are from boundary layer theory, displacement thickness, boundary layer thickness, momentum thickness, safe factor. There are number of questions based on this model studies, lift and drag coefficient. Okay, so this is basically the part where you have to give more focus. And as far as aerodynamics is concerned, I think 14 to 15 marks weightage is there for aerodynamics, even maybe more, right? Out of which the fluid mechanics part, the weightage is approximately 8 marks, 7 to 8 marks every year on an average weightage is there. So it have a very good weightage. Okay, so shall we start? Aerospace and basic fluid position measure in aerodynamics. Yes, atmospheric and basic fluid position is measured in aerodynamics. Okay, so shall we start, beta? Are you ready, guys? So if you are ready, then make one heart in the chat box so that it will mark your attendance. Okay, let's move with a very simple problem, right? So we have one very simple problem asked for 2 marks. So one very good part I have seen that in mechanical, or like I used to teach mostly for mechanical and civil, like mostly mechanical students. So I have seen that the questions which were asked for 2 marks are little bit lengthy in fluid mechanics, but here you will find very simple problem even in for 2 marks, right? So it is very easy portion, right? And very easy question is in front of you. So the laminar boundary layer over a large flat plate held parallel to the free stream is 5 mm thick. Laminar boundary layer thickness basically given. So delta 1, I can say delta 1 value is given as 0.5 mm. 0.5 mm thick at 0.2 meter, 2 meter downstream to the leading edge. So from leading edge we are measuring the distance, and that distance we are measuring like x. So x1 value is given as a 0.2 meter. 0.2 meter, right? Now the thickness of the boundary layer at the point x2 value is given, that is 0.8 meter, and they will ask delta 2 value. This type of questions were asked in every single branch, mechanical also, civil also. These type of questions are, number of questions are there. Very good, Stark, very good. So here how to solve this? Very simple. Blasius equation we'll use, and according to that, delta by x is equal to k by under root re. K by under root rex, right? So this is basically what, this is the formula, right? K values generally vary from 4.5 to approximately 5. Generally, if it is not given, then we used to consider 4.91, right? If K value is not given, then we'll consider 4.91 mostly. Okay, but it's not relevant for us. So delta is equal to, we can write kx by under root RE. Under root RE can be written as rho Vx by mu. Rho Vx by mu, right? Now here, as per given the data, only x is changing, my dear student friends. All other things are same. All other things are exactly same. So I can say that this is delta x, this is root x. So delta is going to proportional to under root x. Delta is going to proportional to the under root x, right? Now so I can write here delta 2 by delta 1 is equal to under root x2 by x1. This x is always measured from the leading edge. I have seen number of questions. I have taken only 1-2 question here, but I have seen that number of questions are there exactly similar to this. Okay, so delta 2 value we need to find out. Delta 1 value is 0.5 mm or 5 mm? 5 mm, sorry, it's not 0.5, it is 5 mm, right? Okay, so this value is given as a 5 mm. No need, like, because answer is coming in mm only, so you can put in mm only, and this is a ratio, so unit is not affect. So delta 2 value is 0.8 divided by 0.2. Point cancel out, it will become 4, it will become 2. So delta 2 value will come 10 mm. 10 mm. Okay, delta 2 value will come 10 mm. So B is going to be your correct answer. It's a very simple problem, very important problem. Okay, let's move on to the next problem. Let's move on to the next problem. Okay, try to solve this. I'm not able to see the comments because let me check. Wallah. Add आ रहा है. अरे sir, you are a teacher, at least you should have premium. And now I'm able to see that, right? Now I'm able to see your comments. Okay, so please solve this problem. Right, now please see the problem. Actually, my old I have a big TV here actually earlier, but that have some problems. So for and new TV is in transition. So for the change, I have plotted here very small TV, so it's not that much visible. Okay, consider an ideal flow density rho and a variable area duct shown in below. Let's cross section area 1 is A1, okay, and respectively 2 is okay. Velocity measured as section 1 using pitot tube is V1. What is the static pressure difference drop is given. P2 minus P1 is known. So what we need to find out? The velocity measured as section 1 using pitot tube is V1. What we need to find out here? Question is this one only. Consider ideal flow density rho is variable. Density rho through the, okay, density kind of variable area is there. Okay, that's shown in figure. Let's cross section area at section 1 and 2 is given respectively. The velocity measured at section 1 using pitot tube is V1. Then static pressure drop P2 minus P1 only we need to find out. Okay, fine. P2 minus P1 only we need to find out. Okay, so V2 value is not known to us, right? Okay, so first we'll apply here continuity equation, right? First we'll apply here continuity equation. As the density is constant, so I can write here A1 V1 is equal to A2 V2. A1 V1 is equal to A2 V2. So first I will write here V2 by V1. So what is the value of V2 by V1? V2 by V1 can be written as A1 by A2. Fine. This is equation number 1. This is equation number 1. Now we have to find out P2 minus P1. So we'll apply Bernoulli equation. Very good evening, Harry. How are you, Harry? Harry is a very good student. I know. Right, Harry solved it fast. So now I am going to apply Bernoulli equation. What is Bernoulli equation between 1 and 2? So P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g. Ideal conditions are given. So P2 by rho g plus V2 square by 2g plus Z2 plus HL is there, but HL value will become 0 because ideal flow is there, right? Ideal flow. Okay, I will write here HL. So this value is 0 because ideal flow. Ideal flow, that is for real flow basically. Okay. Now it is a horizontal. If you see at section 1 and 2, the Z1 and Z2 is same. We need to find out P2 minus P1. Now G is also G is also cancel out. So P2 minus P1 value will come. P2 minus P1 value will come how much? This will go this side. V1 square minus V2 square by 2. Right, and rho will go this side, right? So into rho. Now let me see the options. Like, okay, V1 square we need to take out. So V1 square will take out. So this will come rho V1 square by 2. Rho by 2. V1 square we are taking out. So 1 minus V2 by V1 to the whole square. Okay, so this can be written as rho by 2 1 minus A1 by A2 whole square into V1 square, right? So that is basically P2 minus P1. P2 minus P1, okay? So which one is correct? C is correct. Sorry. 1 minus A1 by A2, 1 minus A1 square by, yes, B is correct. B is correct, right? Very good. B is correct. Very good. Stock, Ananya, no, Arya or Ananya. Okay, Arya. Okay, let's move to the next problem. Now this problem is also asked for 2 marks, 2 marks in 2009. Very simple problem. Even similar kind of problem we have already solved. So here given the laminar boundary layer large plate parallel to the flow, delta 1 value is here. Here two things are given. Delta 1 value is 7.2 mm. Thickness point x1 value is given as 0.33 meter. Downward acceleration, if the velocity of the steam is increased by 50%, means V2 is going to be 1.5 times of V1. Velocity is going to be 1.5 times of V1 increased by, okay, then new boundary layer thickness at the location will be, okay, then the new boundary layer thickness at this location, okay, location is not changing. It means that x2 value is also same. X2 value is 0.33 meter only, right? The laminar boundary layer large plate 7.2 point downward stream. The free stream velocity increased by that. Then new boundary layer thickness at this location will be, okay. So same location they are asking. So again same formula will be there. Delta by x is equal to k by under root RE, right? So delta value will come here kx by under root rho vx by mu, right? So here it will be x. So basically delta is going to be proportional to under root x by v, right? Because x value is same only. So delta 2 by delta 1 value will come under root x2 by x1 into under root v1 by v2. So this x1 x2 is same only. So delta 2 by delta 1 7.2 is equal to, this value is same only, so under root v1, let's say, okay, v1 I'll write v1 only, this value I have 1.5 v1, so delta 2 value will get from here. What is the answer? So 1 by 1.5 under root of this into 7.2. So this value will come 5.9 mm. 5.9 mm. C is the correct, na? Check. 5.9 is correct. Great, Harry. So, Mr. Harry, you have any जादुई छड़ी, मैजिकल जादुई छड़ी है कोई है इसका आंसर भवा तुरंत आंसर आ जाएगा. Okay, let's move to the next problem. Okay, this is also very simple problem, marks for 2 marks, right? So very simple problems are there, and that too also for good marks. So consider an incompressible 2D 𝐂𝐻𝐡 flow. 𝐂𝐻𝐡 flow means one plate is going to be fixed, another plate is going to be moved, right? 𝐂𝐻𝐡 flow and 𝐂𝐻𝐡 flow, 2 walls is spread at 1 meter apart. Oh, okay. The lower wall is kept straight. What is the shear stress acting on the lower wall if the upper wall is moving at the constant speed of 2 meter per second? Okay. So tau basically we need to find out, right? So here we'll apply a Newton's law of viscosity. Newton's law of viscosity will apply. So tau is equal to, basically we already, tau is equal to mu du by dy. Mu du by dy. Okay. So mu value is given how much? Mu value is given 7 into 10 to the power minus 3 into change in velocity by change in distance we can consider. So basically whenever, see, we are not sure what will be the velocity profile, but here velocity is going to be 0, here velocity is going to be 2 meters, so something like that, right? So the velocity profile will come something like that here, right? So the du by dy, this is du. So change in velocity value will come how much? That is 2 minus 0 divided by distance value from, this is a reference only we are considering. So y2 minus y1 value will come 1. y2 minus y1 value will come 1, right? So 14 it will come, right? So this value will come 14 into 10 to the power minus 3 Newton per meter square. So D is going to be, see, such a, like, even if you not even solve, then also you can predict the answer without any calculator, that too also for 2 marks, right? So what I have observed, right, what I have observed that in case of aerospace branch, if you are good in basic subjects, they are asking good number of questions from the basic subjects, and simple question also they are asking, right? Solve this. Consider the study 2-dimensional zero pressure, no pressure gradient is available. A laminar flow of air over a flat plate as shown below. The free stream velocity is given. This is u infinity here. Okay, the condition are given, right? So these are given the condition of the fluid at free stream. So u infinity value is given, right? Means u infinity means free stream velocity, the density of the free stream, pressure of free stream, viscosity of the free stream, everything is given here, right? The ratio of displacement thickness to the momentum thickness, right? Delta by delta displacement thickness delta star by theta. We need to find out delta star by theta. So here profile is not given, right? So you can consider the linear velocity profile, or Blasius equation direct you use. Directly better you use the Blasius equation. Use the Blasius equation for calculating delta and theta. Solve this. See, what is the answer? So delta star value by x is equal to 1.721729 divided by under root rex, and theta value if you calculate you will get 0.664 divided by under root rex. These are the Blasius equations, right? Now they are asking the ratio at the same point, all other conditions also same. So Reynolds number is going to be same only at given condition and given location. Reynolds number is going to be same. So if you divide equation number, this is let's say equation number 1 and this is equation number 2, theta by x, sorry. So if I divide equation number 1 divided by equation number 2, so you will get how much? Delta star by theta is equal to 1.729 divided by 0.662. So this value if you solve, 2.6 approximate, you will get 2.6 approximate, 2.596, 2.6. Yes, 2.60, correct. Aryan. Arya, sorry, not Aryan. Sorry. So the x and y component of two-dimensional flow. So u value is basically given, right, and v value is also given. So find the streamline equation. So equation of streamline. Equation of streamline. Equation of streamline, if you talk about, that is nothing but a dx by u is equal to dy by v. So we can write here dx by u value is cy by x square minus plus y square is equal to dy by v value is tx by x square plus y square. Minus or plus, both are plus only. Sure. Okay, no problem. So here if you see, few terms are going to be cancelled, x square by y square, x square by c, right? So basically you are going to get here like y dy is equal to x dx. Y dy by x dx or x dx minus y dy is equal to 0. If you integrate this, so you will get x square by 2 minus y square by 2, right? So this is basically a hyperbola equation. Hyperbola, na? Yeah, hyperbola. This is a hyperbola equation. This is the equation of hyperbola. Oh wow, this is really a beautiful problem. This is real. I want that you people answer first. You people answer first, then I will give the answer. This is a really a great good problem, and there may be possibility that some of the student may confuse. So here first of thing that unsteady flow. Unsteady flow means for steady flow we have already seen that for steady flow streamline, streak line and path line all are going to be same, but it is unsteady. Very good, Arya. Acha, Arya already has solved previous year question. I hope so. Maybe. Okay. Now okay, so you just have to tell that which line it is, right? So the bubble set are traced particle and follow the flow faithfully. See, injected at point A. See, so what is a streak line? Basically try to understand. Everyone, first you give me the answer. Everyone give me the answer. Harry, you to tell me. Harry, yes, Papa. Eating sugar, no, Papa. Telling lie, no, Papa. Okay, so you people are correct, right? So this is a streak line basically, right? Streak line. So what is streak line? I am explaining this. So streak line is the position, like current position of the molecules or current position of the molecules, current position of the molecules which are passed through the same point matching with the initial point. So let's say this is it is something like this system. Here some bubbles are coming out, right? So the first bubble is coming out like this. First bubble will be reach here after some time, second bubble, third bubble, right? So if you add all these, right, this is not a same bubble moving. These all are different bubbles. So this is a different bubble, this is different bubble, this is different bubble, this is different. So at a particular time we are matching the current location of each. So this is basically streak line. This is basically called as what? Streak line. Streak line. So streak line is the correct answer. Everyone is agree with this? If anyone have any confusion, you can ask. Wow, this is really a good problem. This is really a good problem. Now here it is given that for study incompressible two-dimensional Cartesian coordinate system and dx by dt. What is dx by dt? Displacement per time. That is nothing but a velocity, means displacement in x direction, that is represented by u. So u is equal to basically dx by dt, and that value is basically given as ax, and v value is basically dy by dt for dt, dy by dt, and this value is given as by. Now a and b are constant. Okay, a value is given as a 5, then b value they are asking. Very simple. Somewhere incompressible will be written. Yes, this one, incompressible, right? So for incompressible fluid flow, my dear student friends, for incompressible fluid flow, continuity equation is dou u by dou x plus dou v by dou y is equal to 0. Dou u by dou x plus dou v by dou y is equal to 0. So dou u by dou x value will come how much? A. Dou u by dou x value will come a, plus dou v by dou y value will come b, that is equals to 0. So a value is given as a 5 plus b is equal to 0. So b value will come -5. So -5 is the correct answer. Check. Yes, correct Harry. Correct Arya. Ananya, Arya. Whoever is present here, please let me know from which college do you belong or place you are belong. From which place you are belongs. Everyone who is present here, let me know which place you people belong from, and if possible college name. Aligarh, okay, very good. Andhra Pradesh, wow. Where in Andhra? TPM, I know you, yaar. TPM, you are solving problems of TPM is solving the problem of fluid mechanics also. He is a very good student. Hopefully, you people will see a good rank this year. I am hoping a lot. Funny Mohan, I know you, bhai. Funny Mohan, how is your test marks are going on? कॉलेज नेम तो सर रैंक आने पे रिवील करे. क्या बात है यार, वेरी गुड. Subject matters here, sir. Correct. Very good, TPM. TPM, tell me, how is your marks in test series, full length test? How many, like what is the average marks that you are getting nowadays? Because I hope that you are solving test series. कॉलेज रैंक तो आर्या बताएगा. हाय हाय, नोएडा आके बताऊंगा सर. हैं, अलीगढ़ से नोएडा की तो ज्यादा दूर नहीं है सर, पहुंच जाएंगे 10 मिनट में, नहीं 1 घंटे में. 1 घंटे में पहुंच जाएंगे अलीगढ़ से नोएडा, वहीं पे बताएंगे सर. ओके. So the velocity profile for incompressible laminar boundary layer flat plate. So u by u infinity is given, right? U by u infinity is given. So that is basically 3y by 2 delta minus y cube by 3 delta. The free extreme velocity u infinity value is given as a 10 meter per second, and the dynamic viscosity mu is also given. Okay, great. So mu value is given 1.8 into 10 to the power minus 5 kg per meter second. Okay. Now add a stream wise station where the boundary layer thickness delta value at delta is equal to 5 mm, the wall shear stress tau you need to find out. सर 75 to 80 मार्क्स के बीच में. इट्स वेरी गुड. अभी इंडस्ट्रियल स्ट्रॉन्ग करा, बिल्कुल स्ट्रॉन्ग करो. टीपीएम यू वी आई पर्सनली राइट, I personally have a very good faith. I have very good belief that you are going to get very good rank, hopefully rank 1, right? My gut feelings are saying that, not gut feeling, my heart is saying that, my heart is saying that you are going to be like rank 1, 2, 3, either 1, either 2, either 3. So in any subject, if any problem is there, TPM, you just let me know. If I will able to help in any manner, I will do. Right? In any subject, any kind of problem is there, you just let me know. We can do like, we can do some, if you required, I can arrange some Zoom session also along with me, or the subject which you are facing problem. So in any subject, if you are facing problem, we will I will personally discuss with the relevant like respectively faculty, and then I can arrange the session. But you should be like in top-notch rank. Sir, I have problem PYQ test series देने पे I got 60-70 marks, but other it's good. यार Arya, please try to understand. Arya, please try to understand which kind of question IIT is going to frame. The same like test series or the same like PYQs? Obviously PYQs, right? PYQ is more relevant for gate or test series is more relevant? So obviously PYQs, right? So there might be the point wherever you are solved, like I think gate wala test series is there for aerospace, because aerospace started this year only, that too also for gate 2027. So I hope for next year student, the student who are preparing for gate 2027, they will get test series of gate wala. I hope currently there is no test series, right? So sometime being a faculty, teachers also consider that, okay, give little bit tough problems, but you can see that simple problems are there. There is no test series for gate. Yeah. So there is no gate. No, no worry, Arya. No worry, Arya. You are getting good marks. You have still approximately 20-25 days. Just see where is the major mistake, which subject you have major mistake, what type of mistakes you are doing. Just try to analyze this and accordingly revise the subjects, right? You will get good rank. I personally have seen that, believe or not, I personally have seen that the student who are getting in test series some 60-70 marks, they used to get 80 marks. Like I can say today itself for TPM, okay, I will not say anything because नजर लग जाती है, right? मुझे नजर नहीं लगाना, मेरा favorite student है. Okay, so what we need to, what is the answer you got? Tau is equal to given, so mu du by dy you can put, no problem, right? So first u is equal to you can write u infinity means 10, right? So 10 into 3y by 2 delta minus y cube by What is 3 delta here? No. This I'm writing wrong actually. Sorry. 3y by 2 delta, 1 by 2 y by delta cube. Y by delta cube, right? So y by delta u is equal to, so if I calculate du by dy, so 10 3 by 2 delta minus 3y, here 1 by 2 is also there, 3y cube by 2 delta 3y square, 3y square by 2 delta square, 2 delta square, right? Is it correct? 3y by 3 by 2 delta, correct? 3y square by 2 delta cube, right? Now at delta is equal to 0.005 meter, 0.005 meter, delta is equal to 0.005 meter, du by dy, calculate du by dy at delta is equal to 0.005. What is the value of this? Well, let me calculate for you. So 0.005 to 2 into 0.005, अरे कैलकुलेटर को क्या हो गया है, 2 into 0.005, 3 by delta, $300. So this value will come 10 into 300 minus 60,000 y square, 60,000 y square. Okay, then mu is equal to tau we need to find out now. So tau at y is equal to 0, because at wall shear stress they are asking, right? So at tau y is equal to 0, du by dy value will get 3000, right? Tau is equal to mu du by dy. So mu value is how much? 1.8 into 10 to the power minus 5 into 3000. or we can write 54 into 10 to the power minus 3 Pascal. How much? 54? Yeah, correct. There is no test series for aerospace, not anywhere. No institute is providing what you are writing here. TPM. TPM you are writing delta 3, delta Q. Okay, here. There is no institute which is providing aerospace. No, GATE wala you will get. GATE 2027, I am 200% sure that in GATE wala you will get test series, but for GATE 2027, because we don't have like we have batch for GATE 2027 we launched na. This year only we launched actually. So next year you will get, but you have to get rank this year only. Okay, try to solve this problem. Everyone got this answer? Everyone got the answer 54? Everyone got the answer 54? Okay, solve this problem. Consider the incompressible flow over a flat plate with the following approximation velocity profile. So up to delta like y is equal to up to delta, y up to delta, actually the velocity profile is linear, right? So where delta is the boundary layer thickness, use a free stream velocity, the normalized momentum thickness we need to find out for the profile is. Please solve this. So up to delta you can consider here u by u infinity I can write for easy, otherwise you will confuse what is this u. U infinity is the free stream velocity, that is equals to y by delta you can consider. Okay, so this is a velocity profile, linear velocity profile. Okay, delta is the normalized momentum thickness theta by delta we have to find out. Okay, momentum thickness, not displacement thickness. So shall I move to the next slide? Okay, first you write down the question, then I will move to the next one. Please solve. It's a very simple problem. I hope you have already, some people may already remember the value also. Some people may remember the value also. Okay. So here, what we have to find out? Momentum thickness theta. Okay. So theta is equal to 0 to delta u by u infinity 1 minus u by u infinity dy, right? So just write here, so 0 to delta u by y by delta, right? So this value I can add y by delta 1 minus y by delta dy. This value will come 0 to delta y by delta minus y square by delta square dy. Now integrate this, so you'll get a y square by 2 delta y square by 2 delta minus y square by 2 delta minus y cube by 3 delta square from 0 to delta. Now put this value. So here you will get delta by 2 minus delta by 3. So you will get delta by 6, I hope so, right? So theta is equal to delta by 6. So theta by delta is equal to 1 by 6. 1 by 6 is how much? 1 by 6. So this value will come 0.1. Okay, solve this problem. Everyone solve this problem. So here given that an idealized velocity field, so I cap is given, u value is given, basically u value is given 4tx, v value is given as 2t square y, w value is 4xz, right? At point this one x1 y x y z value is given, t value is also given. The magnitude of material acceleration velocity of the fluid, total velocity vector you need to find out, TPM, total velocity vector you have to find out. So I already told you, whenever you have to find out total velocity vector, a is basically we can consider like ax I cap plus ay j cap plus az k cap. So ax, ay, az you have to calculate, and they are asking the magnitude, right? So magnitude of a value will come under root ax square plus ay square plus az square. So only ax, ay or az, you have three things you need to find out. Only three things you need to find out. So what is the value of ax? Ax value you have already seen that u dou u by dou x plus v dou u by dou I plus w dou u by dou z plus dou u by dou t. Correct? Okay. Now u value is known. Dou u by dou x value will come 40, right? So this value will come u value I will write. Will 4. Oh, अरे पेन क्यों नहीं चल रहा? 4tx, अरे क्या हो गया? 4tx into dou u by dou x. Dou u by dou x value will come 4t. Okay, plus dou u by dou y. Y, it is not function of y, so this term is going to be 0 because u is not directly, right? I'm not writing, but please try to understand. It is u is not function of y, u is not function of z also, so leave it. Dou u by dou t value will come how much? Plus dou u by dou t, 4x. So at given point, at x is equal to -1, y is equal to 1, z is equal to 0, and t is equal to 1. So here x value is -1, this value is t value is 1, right? So -1 if you put, this is 1, -14, minus start of -16, -12 will come, right? AX value is minus 12. Is it correct? Check. AX value is minus 12. Check please. Because this value T is positive 1, this is negative 1. 4 16, 16, correct. Similarly, AY, similarly I am writing, same formulas are there. Similarly, AY value if I write, similarly I am writing, you people do the complete calculation. So AY value will come, U is not function, so only V term will come. V means 2T square Y into 2T square Y into dV by dy. dV by dy is 2T square plus dou V by dou T, 4Ty, right? 4Ty. Yeah. Okay. So AY value will come at this particular point. Y value is 1, T value is also 1. So Y is 1, this is also 1. 2 2 ja 4, 2 2 ja 4, 4 4 8. Please check. Please everyone tell me the values. AX value tell me, AY value tell me, AZ value tell me. अरे भाई X value is minus 1. Oh, sorry. X value is minus 1 na. X value is minus 1. So this term will come minus 16 minus 4. Minus 20, sorry. AY value tell me whether it's correct or wrong. Similarly, AZ value I'll calculate. So it is also function of Z only. So W 4x Z into 4x plus it is not function of T also. Oh, no. It is function of X also, right? So 4Tx U do W by dou X 4Z plus W 4xz 4x. So T value is 1, Z value is 0, right? Oh, Z value is 0, isn't it? Yeah, so this term also Z is there. This term also Z is there. So 0 only. This value will come 0. So A value will come under root minus 20 का square plus 8 का square plus 0 का square. This value will come 20 का square plus 8 का square under root of this 21.54. Is the correct answer is 21.54. This is 12. This value is coming 12. This value is coming 12. How? T value is 1. Okay. Y value is 1. Okay. T y 2 2 ja 4. ठीक है. T value is 1. Y value is 4 4 88 value will come. 21.54. Please check and let me know. No sir, 20. Sir, V component is, see here. So V here it will come U dou V by dou X. So dou V by dou X value 0. Remove. V dou V by dou Y. So V 2T square Y. Oh my God. This value is negative. sorry. This value is negative. Sorry. Now again answer will change. So this value will be negative. This value will be negative. So v dou v by dou t. Okay, that is correct. Then dou v by dou t. V dou v by dou, it is also come in minus, and this value will come minus 4ty. Minus 4ty. Okay, now put the value. So this value will be minus plus, t value is 4. This value will also come 0. This value will also come 0. This value will come 0 square. This value is 20. 20 is the answer, not minus 20. Not minus 20, plus 20 is the answer. Not minus 20. Okay. I did mistake. Answer is plus 20, not minus 20. एक भाई ने फिर से Okay, this question you solve. Sir, we are giving components of A. We are giving components of A. Components of A, they are not asking. The magnitude of material acceleration. Right. So magnitude of material acceleration means this formula you have to use mod x. Right. Magnitude they are asking, my dear. TPM. Magnitude they are asking, so answer will come plus 20 only. Ax value is minus 20, right? So this value will come basically A is equal to, it will come like vector sum here, right? A value will come like minus 20 cap. So when you calculate the magnitude part, it will come only 20 plus 20. Okay, solve this problem. In the figure below, water exits from the nozzle into atmosphere. So the final pressure is P2 value is atmospheric pressure, and exit velocity is also given 8 meter per second, and neglect the friction, the magnitude of axial force. Okay, force at okay. So if you want to find out force, flange. Okay, so this I am going to consider section 1. This I am going to consider section 2. So you need to know what, right? If you want to find out force, means momentum equation you have to use, linear momentum equation. So for momentum equation, here force will come due to two reasons, right? One is because of the velocity changes, correct? And another one is due to pressure, right? So pressure changes. So due to pressure change and due to velocity change, the force will come. So basically first we need to know what is the value of P1 and V1, right? P1 and V1. So let me apply here continuity equation. First you apply A1 V1 is equal to A2 V2. Now tell me what is the value of A1, no, V1. Now calculate V1 value from here, right? Then apply P1 by rho G plus V1 square by 2G, right? Z1 Z2 is same, Z1 Z2 neglect, is equal to P2 by rho G plus V2 square by 2G, right? P2 value is given, right? P2 value is given as 101. This is P2 basically. This is, you can write P2 absolute value if you want to find out. Then from here you will get P1 value. These two things you find out, then apply momentum equation. Solve fast. Oh my God. Everyone solve this. Just apply Bernoulli equation, then apply first apply continuity equation, then Bernoulli equation, then momentum equation. Yes, density you can take 1000 because water given na. Solve fast. What is the answer that you got? P2 value is 422. What is P2 value that you got? Final answer is 91. Final answer you are saying, okay. Minus 91, okay. 11 Newton. 11 Newton, huh? 11, okay. Let me check, okay. So what is the V1 value? Can you tell me? Area is how much? 8 centimeter and it is a 4 centimeter. Area is going to be half, so area square means half square means 8 to 2. So velocity value will, I think it will come 2 meter per second. Is it 2 meter per second? A1 V1 is equal to A2 V2. Area is square proportional to 2. It will come 16. Here 2 meter per second will come. सर क्या अभी गेट DA 2027 टेस्ट सीरीज परचेज तो टेस्ट तो चुके हैं. हाँ, you will get access 2 meter per second. I hope so, right? Because V2 is given, V1 we need to find out, right? So 4 का square 8 का square. Yes, correct. 2. So and P1, this value, pressure value will come how much? V2 square minus V1 square. If I take it as a 0, gauge pressure should I consider? P2 minus P1 is within milligauss. So P2 value I am taking 0. Why? Because gauge. I am taking gauge pressure because anyhow we required gauge pressure only, P2 minus P1 only, right? So P2 value I am taking 0. So V2 square 8 square minus 2 square. So 60 square 8 square minus 2 square divided by 2g. G is cancel out, right? G is cancel out by 2 into, so 30,000 means 30 kilopascal. 30 kilopascal. Is it correct? Is it correct? Right. Now we need to find out force on this nozzle, right? Force on nozzle will come how much? M dot into V2 minus V1 and plus P2 minus P1 into area. This value will come, na? Is it correct? Check once. So M dot value will come how much? M dot value is rho AV. Rho value is given? No, rho value is known. So rho A1 V1. So rho value is 1000. A1 value is pi by 4 into d square. Pi by 4 d square, 0.08 का square by 4 d square. So A value into 1000 into 2. So this value will come 10.0531. So this value will turn into V2 minus V1. V2 minus V1, 8 minus 2 into 6. This value is 60.331. 60.31 60.31 area was how much? Pi by 4d square. अरे यार इतना वैल्यू हो गया है कि मुझे याद ही नहीं आ रहा है. m dot value. You just solve this, put the values. Put the values at sir. अभी गेट बताया तो मयंक गुप्ता. अभी गेट डी टू टर्निंग सर से परचेज करूंगा तो टेस्ट हो चुके. यस पूरा एक्सेस मिलेगा. You will get access of all the questions. You will get access of all the questions. Don't worry about it. You will get access of all the questions. I think this value will come V2 minus V1. 10.100531 into 6. So this value will come 60.31. I will write plus P2 minus P1 value will come 30,000 into अच्छा P2 value is going to be 0, so P1 value we need to consider. Okay, P2 value is going to be 0, atmospheric condition na. Pi by 4 into d1 square into 0.08 per square pi by 4 d square into 30. So minus 60 point. This value will come is P1 minus P2. So drop actually is considered. So minus this value is coming 150.8, right? 8. So this value is coming minus how much? 150.8 minus 60.31. 90.41. Right. So axial flange location 1 they are asking, you know, attached to the pipe. Magnitude only they are asking. 90.5 Newton. Nearest integer you have to write. Nearest integer what to write? 90.5. In this question 90 and 91 both will be considered as an answer, don't worry, because nearest integer means like some people may write only 90, some people may write 91, so both answer will be correct. 90 and 91 both will be correct hopefully. Okay, solve this problem. Everyone solve this problem. Solve fast. Solve this problem. This is really a good problem, I would say. So here given that a football meant to be thrown at 100 km per hour in a sea level air, rho value is given, mu value is given, is to be tested using 1/4 scale model in the water. So basically the prototype is in air and model is in water. Conditions are given, dynamic similarity, the ratio. Okay, so it is a football and the flow is over the football. So whenever flow is over body, right, then Reynolds law of similarity is going to be used. So Reynolds number of model, or I can say air in air, must be equals to Reynolds number of in water, right? These two. So rho V d by mu of in air is equal to rho V d by mu in water. So in air rho value is 1.22. So 1.22 into velocity is 100 km per hour. Should I write in velocity meter per second? Will be fine. Yeah, meter per second will be fine. Yeah. Okay. Okay, first I'll write 100. We'll convert later. Okay, 100. D value is the 1/4 scale. 1/4 scale. Okay. Quarter scale means D value will be reduced in D by 4 here. So here it will be D only I am writing. Here I am writing mu value is 1.7578. 1.78 into 10 to the power minus 5. This is D in the air. That is equals to, or directly is equal to rho value is 1000, V value is V in the water. I am writing V in the water. D is equal to D by 4. D by 4, 1/4. So 1/4 means you are understanding what is the scale ratio is given. Means dm by dp. dm by dp value is given, right? Divided by mu. Mu value is 10 to the power minus 3. So from here calculate V in the water. Calculate V in the water from here, meter per second. No. This value will come kilometer per hour. Because 100, yes. This value will come kilometer per hour. Now we already know that CD, coefficient of discharge, is equal to drag force by half rho V square A. So FD value will become proportional to rho V square A, right? CD value I'm taking same, right? So the ratio of the model force, right? So the force in model by force in prototype. So rho of the model is water, na? Rho of the water by rho of the air into V of the water to the V of the air square into area pi by 4 d square, pi by 4 d square. So d of water by d of air whole square. Oh, no, whole square. So a is equal to pi by 4 d square, right? You just calculate these values first. You tell me what is the VW value? So this value will come like 1.22 into 100 divided by 1.78 divided by 10 to the power minus 5 into 10 to the power minus 3 divided by 1000. कितना आ रहा है, गड़बड़ हो गया कुछ. 1.22 into 100 122 divided by 1.78. Okay. This value will come 27.4157. So rho of the by okay, d of the water is d by 4. So into point. Is it 3.85? 3.85, yes, correct. $3.85. Check. 3.85. Everyone check. Nearest integer you have to write. In this case, nearest integer will be 4. So 4 will be correct. Yes, correct. TPM, is it correct? Next problem. Next problem. The boundary layer thickness at the location of sensor on the flat plate is an incomplete laminar flow requested to be restricted to 1 mm. The boundary layer thickness delta value is given. 1 mm. Okay. For the effective measurement, okay, if the flow velocity is v is equal to 20 meter per second at 1 bar, okay, 300 Kelvin temperature, and viscosity mu value is given as 1.789 into 10 to the power minus 5 kg per meter second, SI unit only. The maximum distance of the sensor location from the leading X value they need to find out. x value you need to find out. So here you can write what is the boundary thickness laminar na. So delta by x is equal to 5 by under root RE. This formula we need to use. 5 generally we are taking if no, actually this is a k by under root RE, but k value is 4.91 to vary to the 5. So if it is not given, so we can consider 5, no problem. We can consider 5, no problem. Solve fast. So delta value is given basically. So delta is equal to 5x by under root rho v d rho v x by mu. So here under root x will be remaining. So delta value is 1 mm. 1 into 10 to the power minus 3 is equal to 5 into under root x divided by under root rho. Rho is how much given? Air is there. Okay, rho is not given. V is given how much? 20 meter per second. Mu is also given. That is 1.789 into only rho is not given. So apply here P1 V1 is equal to P1 is equal to rho P is equal to rho RT. P is equal to rho RT. T1 V1 is equal to, actually we can write like this if you are not able to understand. PV is equal to MRT. For here PV is equal to MRT. P will be M by V is rho RT. So rho is equal to P. P is how much given? P is 1 bar 10 to the power 5 लिख लो 10 power 2 लिख लेता 10 to the power 2.287 into T is 300 Kelvin. Rho value will come 100 divided by 300 divided by 0.287. This value will 1.161. I think x is equal to, it will come 0.051937 meter. mm में ना 51.93. देखो ये आंसर आ रहा है 51.93. Yes, correct. Shall we move forward? Okay, solve this problem. Sir, how was your experience in Gate Aero branch? Sorry, I will not. I will not. I don't believe on misguiding actually, right? So I don't believe on misguiding. How was your experience in Gate Aero? Okay, okay, sorry, okay, okay, fine. You are asking about Gate. It was very good. Very good students are there. Generally, earlier also during offline, I taught some batches for aerospace, and what I usually found, maybe my mechanical student may don't like this sentence, but frankly speaking, I have observed that aerospace students are very much sincere. Very much sincere. Either they will not prepare or they will prepare very sincerely. So this is the difference I have seen in mechanical and aerospace. So recently, I think last month only, I have completed a basic thermodynamics for aerospace branch for batch GATE 2027. Students were very good, very good. They are able to understand the concept very easily. Correct. Like, too much effort is not required. Being a faculty, being a teacher, it is very easier job for us compared to mechanical and other branches. Okay, solve this please. Everyone please solve this. Yes, correct. So to simulate the aerodynamic forces on cylinder, so over the flow means Reynolds number will come 1 meter diameter due to uniform aerodynamic forces cylinder diameter. Flow is this one, standard temperature STP, the lowest steep wind tunnel experience STP, 0.1 diameter cylinder. Okay, this is very, so d1 dp I can write dp value is 1 meter, vp is equal to 1 meter per second, dm value is 0.1 meter, the free extreme velocity of air. To simulate the aerodynamic force on cylinder of 1 meter diameter due to uniform airflow of 1 meter per second at standard temperature and pressure, low speed wind tunnel experience STP are conducted 0.1 meter diameter cylinder. The free extreme air speed in the tunnel wind experience should be. Okay, so we need to find a VM value. VM value we need to find out. So here we'll say Reynolds number of model is equal to Reynolds number of prototype. So rho VD by mu of model is equal to rho VD of prototype. Rho VD by mu of prototype. Achha, both are same, aerodynamic uniform. Okay, so in both the case air is only used, rho mu is going to be cancelled out, so vd of model is equal to vd of prototype. So v of model is how much? V of model we need to calculate, d of model is 0.1 is equal to v of prototype is 1, d of prototype is 1, so Vm value will come 10. 10 meter per second. 10, correct. So you are for Arya. Arya, you are GATE 2027 batch. Are you from GATE 2027 batch? Okay, you solve this. .22 stack. Okay. The thickness of the boundary layer thickness delta value is given like this. Measured from the leading edge length plate, the velocity profile is linear variation. So delta star is equal to delta by 2 for the free stream velocity 3 given. So what we need to find? Displacement thickness we need to find out, right? So displacement thickness delta star is equal to, I'm not deriving it again, right? I'm not deriving. Just like momentum thickness we derived, we can find like this. So this is for linear profile. If anyone have confusion here, then I will derive. Right? If you have confusion in this one, then only I will derive, right? So we need to find out delta. Delta is equal to 5.2 x by under root RE rho V x by mu. So just find out the delta value. So delta value will come 5.2 into x. The displacement 0.5 meter from the leaf. So 0.5 divided by under root. Water is there. अच्छा काइनेमेटिक विस्कॉस म्यू बाय रो इज इक्वल टू न्यू तो वीडी बाय न्यू लिख सकते हैं v value is 3.5 by न्यू 1.5 into 10 to the power minus 5. This value will come 8.222 mm. So delta star value will come delta by 2 is 4. Okay, Arya. Okay. In 2007 batch also, right, 2027 batch also, mostly students are third year students only. So here 4 point round out to 2 decimal 4.11. This part should be clear, because here velocity profile you can like linear is na? So u by u infinity is equal to x by delta, y by delta. Last problem for today. Last problem for today. Everyone solve. Everyone solve this problem. So to estimate aerodynamic load on aircraft flying at 100 meter per hour, right? So the estimate aerodynamic load on aircraft flying, actual aircraft, na? So VP value is given as 100 kilometer per hour. Standard sea level condition 1/5 scale model. 1/5 scale model means Lm by Lp is equal to 1 by 5, or I can say Lp. Okay, it's fine. Variable density wind tunnel ensuring the similarity of the inertial and viscous forces. Okay, inertia and viscous forces you need to consider. So inertia and viscous force means Reynolds number. So Reynolds number you must be use. The pressure used the wind tunnel is 10 times of the atmospheric pressure. Okay, so PM is equal to 10 times of PP, because prototype is going to work on atmospheric pressure only. Ideal gas hold the same temperature. Temperature is same. Okay, velocity needed to wind tunnel test section. So Vm value you need to find out. So here I will use here Reynolds number of model is equal to Reynolds number of prototype. So rho VL by rho V d by mu. Rho VL by mu is equal to rho model is equal to rho VL by mu of prototype. Right, so same gas is going to mu is going to be cancel out only, but the problem is rho, because such a pressure difference rho will definitely change. In such a pressure difference rho will definitely change, right? So for that we can write what should write so P is equal to, we can write here rho RT. So in place of rho I can write P by RT. So this can be P VL by R mu T of model is equal to PVL by R mu L by prototype. So temperature is constant given, right? So this term is going to be cancel out only. No need to cancel, but okay. So we have to find out V of model, right? So V of model is equal to P of prototype by P of model into V of prototype by V of model. No, V only we need to find out. L of prototype by L of model into V of prototype. So P of prototype is 1 by 10, P model by 10. So this value will come 1 by 10 into LP by LM value is 5 into VP value is 100 50. Check once. 50 km per hour is going to be the correct answer. So B is going to be your correct answer. Just check once. So this is all about today's session, right? So mostly we discuss the fluid mechanics part today, and if it will be possible from my side, we will see some more session on aerodynamics. Don't worry about it. So today we have covered only basics part of fluid mechanics. So in basic fluid mechanics part, basic thermodynamics I have completed, basic fluid mechanics also completed. So in basic fluid mechanics, I would like to suggest you few topics, right? Let me write here. Where is that? No, topics are not mentioned here. Okay, I'll convey here. So mostly if you see in last few year, what is my observation about basic fluid mechanics part. So as far as basic fluid mechanics is concerned, fluid static portion I have seen very less number of questions, right? Core aerodynamics will be there most, like let me check one schedule, right? Let me check one schedule, and if it will be required, I will go with that, right? Or maybe Vinay sir or someone else will go through it. We will see. So mostly what I'm trying to say, that in this part, what I observed, the in fluid static portion is not that much important, so don't practice much, just go through it. Properties of the fluid, pressure measurement, hydrostatic forces, and buoyancy and all, just go through it, right? No need to give much attention for that. Start like revising more and more in fluid kinematics. In fluid kinematics also, 5 parts maximum, 5 parts, right? So streamline equation, 1 part, streamline equation, continuity equation for incompressible flow, correct? Acceleration analysis, right? Acceleration, and then rotational component, omega, vorticity and all. Then next one is vorticity, then velocity, potential function, stream function. That's it, right? So these 5 things you have to focus on fluid kinematics. Then fluid dynamics, I did not find any question on angular momentum equation, so I will suggest you Bernoulli equation, right? Continuity equation already told, right? Bernoulli equation, continuity equation, and then linear momentum equation. Then I did not find any much questions on like flow through pipe and all. Directly come to the boundary layer theory. Lift and drag. Dimension analysis, model studies, even turbulent flow also there is no problems, right? So these things you can have. Yes, major is boundary layer theory, lift and drag part. Boundary layer theory, lift and drag, And this dimension model studies also. Model studies also, lot of questions are there. Few question only I have taken, few more questions are there. So model studies also very much important, especially Faraday law and 90% Reynolds law. 90% questions are Reynolds law. Few questions you may get from the Faraday law. That's it. Okay. So these are the basic fluid mechanics part, and thank you for attending this session. Hopefully we'll meet in some other session also. Okay, thank you, bye bye, see you.